Hello and welcome to another edition of AGD Bytesize, where I give you a small tip to help bring a little more polish to your games. And today we are going to be looking at displaying lives graphically. So rather than display the number of lives that you have remaining as a number, we're going to use some graphics, which is obviously the most common method used in games. So let's take a look at a screen now and see how that will look. As you can see here, I've got three different ways here of showing the lives. The first one is the standard method of displaying it as a number. Then I'm displaying it as an 8x8 graphic, and here as a 16x16 graphic. So I'll show you how to do both of these, and you can choose which one you prefer. As you can see here, I'm using a key to reduce the lives. It's just a bit of test code to show you that it is working. Now, obviously, one of the first things you have to think about when working with graphics like this is making sure that it doesn't go over the edge of the screen. So, for example, if I set the number of lives to 6 here, what you'll see is that the screen will still be fine because it will only display the maximum number that it can. So, for example, here it can only display 4 lives. And as I reduce it down from 5 to 4, down to 3, you'll see that once it's possible to display the lives, then it will do. So that's a safety measure. It means that you won't get any graphical corruptions or crashes because of printing in places that you shouldn't be. Okay then, so let's take a look at the code itself. It's relatively simple and straightforward, so we'll just go through it now. It's stored in the restart screen area, so this happens every time that you restart a screen, which is normally what happens when you lose a life. The screen restarts. As you can see here, I've got the display showing the number of lives. That's the usual way that you get with the default AGD. And then we've got here let line 3 column 26. Should say, of course, I'm using AGDX, which it uses the reduced character set, but you can use this with standard AGD as well. So what I'm doing here, I'm starting with using the variable rand as a temporary variable, and then I'm looping round 5 times, and each time I'm checking if lives is bigger than rand, and then I'm either putting block 1 or block 6. Block 1 is a life, and block 6 is a blank block. As you can see, I'm then adding 1 to rand, and each time it's going through, it's checking are lives greater than 1, our lives greater than 1, our lives greater than 2, our lives greater than 3, and so on. So it will print the exact number of lives that you have, and then it will print a blank block like this, which is block 6, and I'll also show you block 1 here, and that's our little life thing there. You can obviously change the design of that just to show you that in action. Let me just make a couple of changes here, make it a little bit bigger, and yeah, you can do whatever you prefer here, but let's take a look and see how that works. We'll just exit and run the code again, and there you can see it is displaying it. It's a little bit bigger. That's quite good. And as I reduce the number of lives there, you can see the number is displaying correctly. So let's just review that one more time. We're doing a loop of 5, so it's always going to print 5 blocks. And what we're doing here is checking to decide what block we should print. And we do that by using the counter, which is using variable rand. And as long as that variable is less than the number of lives or equal to the number of lives, then it will print a block. And once you get to the limit of the number of lives you have, it'll start printing empty blocks. So when the number of lives changes, it'll automatically overwrite it. So if you, for example, pick up an extra life or something like that, then you can run this code again, and it will automatically overwrite anything that was previously displayed. Okay, so let's take a look at the blocks again here, and I'll show you now how to do it as a 16x16. As you can see here, I've got 4 blocks set up, and they are basically copied from a sprite so that it looks like the character that I'm using. So you can make your own character here using these 4 blocks. And the code, as you might imagine, is very similar. It just has to take into account the change in scale. So let's take a look at that now. And as you can see here, rather than repeating 5, I'm repeating 4. And again, you can choose the number that you want here depending on how much space you've got on your screen. Rand is again 0, and I'm basically starting off by putting block 2 and 3, that's the top half. Then I add 1 to line and go back 2 columns and put 4 and 5. So that basically lines them up so that they display as a single 16 by 16 image. And then obviously once the number of lives is counted and we need to print a blank space, rather than a single block we have to print a block of 4. So we use put block 6 twice, add 1 to line, sub 2 to column, and the same again. Finally at the end we sub 1 to the line, we go back up 1 space, and we add 1 to the counter again, and that will mean that the display will line up for the next 16 by 16 set to be displayed. It's basically the same principle, just a little bit more code to take into account the fact that we are using a larger set of blocks rather than a single block. So now there are a couple of things to consider here. One of the things to remember is this is in the restart screen code. If you want to update your number of lives in the middle of the game, for example if he picks up an extra live or something like that, then you'll have to run this code when that happens so that it updates automatically. And the other thing to consider here is there is another way of doing this, a slightly different option. As you can see here, currently the number of lives on the screen in terms of the number of graphical images matches the number of lives, but that isn't always the case in every game. Sometimes what you want to do is show the number of extra lives that you have. So for example here you have 1 life and it's showing 1 life, but perhaps that last life is in play, and so for example here we've got 3 lives and it means that you have 3 lives left, but in some games you have no lives left and then it will display that you don't have any extra lives left, only the one that's in play. So if we make the adjustment here, I'll show you how you can do that. What I'll do is I'll change this number here to a 1, and we'll do the same for the larger version as well here, and this will change the count so that when you have 1 life left it will display no lives in the graphical section there, so that you know that your last life is in play, just so it's clear. Sometimes players prefer that they know they don't have any spares, so to speak. As you can see, 1 life left, meaning it's in play. Okay, well I think that's it really. I hope you found this video useful. Some of the code that we've covered here will be used in a future video about displaying energy levels, fuel gauges, that kind of thing. It's a little more complex than this, but if you've understood this code you shouldn't have too many problems in implementing that as well. Okay, well all that remains is for me to say thanks for watching, keep enjoying the Spectrum and AGD, and I'll be back soon. Happy coding. Bye bye.